We want to start our work with the real number line by looking at the graphs of some inequalities. And what these graphs will give us is a section of the real number line. Here's our first example. We want to graph the set of all numbers x such that x is less than 1. So what I'm going to do here is put in 0 on the number line for reference, and then 1 over here since it's the endpoint. Now I want to show that I have all the real numbers that are less than 1 up to but not including 1. So what I'm going to do is this. I'm going to put a parenthesis that opens to the left this way, and then color in all the numbers down below that on the number line, putting an arrow in to show that I want all the numbers that keep going in that direction. So this, when I use the parenthesis like this, what it means is that I'm looking for all the numbers on the number line from 1 on down but not including 1. Let's look at another example. In this case, I want to graph all the numbers x such that x is less than or equal to 3 or x is greater than or equal to 1. So let's graph this inequality here first. To do that, I'm going to put 0 in. I'm going to put in -3. And then I want all the numbers that are less than or equal to -3. So I want to start at -3 and go on down. So I'm going to use a bracket like this to show that -3 is part of the solution set. I'm going to color in all the numbers below that and put an arrow to show that it keeps going in that direction. Now let's graph all the numbers x such that x is greater than or equal to 1. Again, here's 0, and I want to kind of line these up. I'll put in 1 over here. I want all the numbers that are greater than or equal to 1. So again, I use my bracket like this that shows that 1 is part of the solution set, and then I'll color in all the numbers up above that and put an arrow in to show that that solution set goes on forever. Now, these two inequalities are connected by the word or, so I want everything that's in this set or in this set. That is, I want the union of these two sets, so everything that's in either one or in the other. So I'll put in my two endpoints, and I really essentially just graph everything that I see. So here I'll have that bracket going up like that. So you can see when the endpoint is part of the solution set, I use the brackets, and when the endpoint is not part of the solution set, then I would use the parentheses. But since this is less than or equal to, and this is greater than or equal to, I know my endpoint is part of the solution set. So you can see in this case I have x less than or equal to 3 or x greater than or equal to 1. So I have these two inequalities connected with the word or. So that I know from the previous section is the union of those two sets. So I'll graph everything from this inequality, that's that. Everything for this inequality, that's that. And then since they're connected with the word or, I put them all together because the word or is union, and I want everything that's either in this set or in this set. So that's what I get down there. Let's look at another example. This time I've got a similar looking kind of inequality, but I've connected the two inequalities with the word and. So let's first graph -3 is less than x. So remember, the inequality symbol always points to the smaller of the two quantities being compared. So this is -3 less than x is the same as x is greater than -3. So I'll put in 0 for reference, put in -3 down here. I want everything up above -3, but not including -3. So I use my parenthesis like that. And I'll draw in all the numbers that are greater than -3, but not including -3. Looks like that. Now I'll go to this inequality, x is less than 1. Okay, here's 0 for reference. I'll put in 1 over here. X is strictly less than 1, so again, I use my parenthesis like this. And I'll graph all the numbers down below 1 like that. Now I go back and check. These two inequalities are connected by the word and, which means that I want everything that, all the real numbers x that do this and also do this. So I want all the numbers that are both above -3 and at the same time less than 1. So that's going to be all the numbers from -3 up to 1, not including -3 and not including 1. So in this case, I get the intersection of those two sets because the two inequalities are connected by the word and. So when I have two inequalities connected with the word and, I end up graphing the part that they have in common, all the numbers that are on this graph and also at the same time on this graph. When it's the word or, I graph everything I see. When it's the word and, it's the intersection of the two sets, and so I only graph the common part. Let's look at our next example. This is called a continued inequality. I have -4 less than x less than or equal to 1, And the way I think of this is -4 less than x and x is less than or equal to 1. This is shorthand notation for two inequalities like this connected by the word and. I know from my previous example that that's going to be the common part, so I'm going to put here -4, that endpoint, +1, that endpoint. I want everything up above -4 but not including -4, so I use my parenthesis like that. I want everything down below 1 and including 1, so I use my bracket like that. And I graph the common part, which is in between here. So this is a continued inequality, and it stands for all the real numbers x that are between -4 and 1, not including -4, but including 1. So this continued inequality notation is really shorthand notation for this kind of notation, two inequalities connected with the word and. It's the intersection of two sets, and so I can read it pretty much the way it looks. X is in between -4 and 1, and that's the way the graph looks. Here's another example. I want all the numbers x such that x is less than -3, or 2 is less than x, which is less than 4. So here I have a continued inequality connected to a simple inequality with the word or. So I want the union of this set with this set. So first let's graph this. X is less than -3. So I'll put in my parenthesis that points to the left here. I'll color in those numbers and put an arrow that shows that that graph goes on forever in that direction. And then I want to put that together with, because this is the union of all the numbers x that are between 2 and 4, not including 2 and not including 4. So again, open parenthesis this way, open parenthesis this way, and I'll color in everything that's in between those two. So I end up with the union of two graphs right here, one of which comes from a continued inequality, and it looks like the colors I've used here sort of match my flowers, so that's kind of neat.